Hi, let's look at another specific heat problem here. It says the problem, a 0.55 gram sample of iron was heated from 298 Kelvin to 1298 Kelvin. It was found that 247 joules of energy was absorbed in the process. Letter A, what is the specific heat of iron? And letter B, how much energy will the same sample of iron absorb when it is heated from 300 Kelvin to 1000 Kelvin? Now, let's break this down into putting all those values in the given. So we have 0.55 gram, which is our mass. And then we have the heating up from this temperature to this. So we have the initial of 298 Kelvin and the final temperature of 1298 Kelvin. Therefore, I'm going to combine these two. I can now solve for my delta T, which is the final minus initial temperature. So 1298 minus 298 gives us 1000 Kelvin for our delta T. And it says there it was found that 247 joules of energy was absorbed. So energy, that is our Q actually. So that's our Q, which is equal to 247 joules. Absorb means it should be a positive value. So that should be clearly stipulated that it should be a positive value. And now we are required to solve for letter A, the specific heat of our substance iron. And what if the temperature changes? What will happen to the Q that will be absorbed in the process? So now let's look at this one by one. So now let's look at our solution. Let's start with letter A. We know our basic formula, Q is equal to MC delta T. However, we are now given the Q, the M, and the delta T. And we are asked to solve for the C. And so all we need to do is derive the equation of the C here, which is because all these three are multiplied, we can just divide both sides by M delta T here, so that your C will be solved here. So therefore, our new equation for C is now equal to Q over M delta T, which is now easy for us to substitute whatever values we have here. So our Q is positive 247 joules over the product of M times delta T. So M is 0.55 gram times delta T of 1000 Kelvin. So I'm going to input this in the calculator. We have 247 divided by the product of 0.55 times 1000 Kelvin. You must be able to get 0.45. This is already expressed in two decimal places. 0.45, and you see the units. No units get cancelled out. So therefore, the unit has to be all together. So joule on top per gram Kelvin. So gram Kelvin. So that is the answer to my specific heat of iron. Now, we're now ready to proceed to letter B. Letter B is what happens to the Q if the temperature changes. So the temperature, the TI here is now 300 Kelvin and the TF is now 1000 Kelvin. So now let's solve first our delta T. Our delta T is TF minus TI. TF is 1000 Kelvin minus 300 Kelvin. We get 700 Kelvin as our delta T. Now, because we need to solve the new Q, the formula of Q is MC delta T. Because it's the same sample, it says the same sample, so the mass is the same, 0.55. The C that we will use is the one we solved from letter A. And of course, the delta T is the new delta T. That's how you're going to approach this. So that's going to be 0.55 gram times the C that we got from part A. So 0.45 joules per gram Kelvin times the delta T, which is now 700 Kelvin. Okay, so that's gonna be all multiplication, and we know that the Kelvin gets cancelled and the gram also gets cancelled. So we're left with the joule unit. So multiplying all of these values in the calculator will give us the new Q value of 172.87 joule. Okay, so that is the answer to letter B. That's the new amount of energy absorbed. It's still positive, but it's lower because the temperature difference is now a little bit lower compared to the initial temperature change. So this is it. I hope that you have a calculator with you so that you'll be able to clarify or confirm if my answers are correct. And again, please do not forget to make good notes on your chemistry notebook, and please be ready to answer sample problems on your own. Again, please don't hesitate to leave in the comments if you have some difficulties and questions. And please don't stop learning, relearning, and unlearning. This has been Madam Narca. And again, please take care of yourself and have a great day. Bye-bye.